Good morning, Vivek and his team. Today we will start one more small topic of P block 16th group. I think this was our topic of discussion where reactivity towards the halogene we get respective halides. So halides of the type EX6, EX4 and EX2 and so on, but most stable halides are from 4 and the 6 OS. And the best example we have seen in 11th class, it was SF4 and SF6. Okay, so under the same chapter, chemical bonding, we have learnt how hybridization happens with the d orbitals by taking only few examples like sp3d, sp3d2, rd2, sp3, dsp3, all those. If d is outside, it is called as outer d hybridization. If d is inside, it is inner d hybridization. That again depends upon pairing of electrons, high spin, low spin, strong ligand, or a weak ligand, or a strong approaching, weak approaching. All that we have studied under the what valence bond theory. Okay, and this year we are going to learn one more better theory, that is crystal field theory, CFT. Okay, so there we learn once again in brief all these hybridization. Okay, so with this let us go to today's class. Yeah, so today's class is what about this. This is that I told you I have taken from the textbook. So question part we'll discuss later. So if you have got a time, then you can solve it. Otherwise, I am there at the end. So there are two types of questions we are going to solve after the completion of chapter or the syllabus. One is textbook questions. Second is board questions. So these two types we'll discuss the moment we complete the syllabus. Till then, let us have an idea or the knowledge about the theory part. Okay, so today's topic of discussion is dioxygen or simply oxygen. So oxygen O2, because there are two oxygen atoms, so therefore the more correctly it is called as what, dioxygen. But simply in our normal language, normal life, day to day writing or explanation, we use just oxygen. Oxygen means it is dioxygen only. Yeah. So the second essence, first essence of our life, oxygen. Okay, so let us know how it is prepared and what are its important properties and where all we use. Okay, so regarding preparation part, the first method is first we have to check among the available chemicals which chemical has got rich amounts of oxygen. Okay, so they are called what, oxygen rich chemicals. For example, potassium permanganate is there, potassium dichromate is there. Okay, potassium nitrate is there, potassium chlorate is there. So all these compounds are called as what, related to the potassium only, potassium and sodium, because that chlorate, permanganate, dichromate, so all those are special units, anions, where from that area we get the oxygen easily by just heating. It is called thermal decomposition of those oxygen rich compounds. So we have made use potassium chlorate, so user friendly. So by taking the potassium chlorate, it is prepared in the laboratory. So 2KCl plus 3O2 are the products, and this is a normal reaction. So if you want to go for a little speed to increase the speed of reaction, then you can go for the black color manganese dioxide. So it will enhance, increase the rate of reaction, so that more amount of oxygen comes out in less time. So by using MnO2 as catalyst, we will carry out the reaction. Without catalyst also we can carry out, no problem. Okay. Only thing is what, it is just to increase the rate of reaction. Otherwise, no other way it is connected, MnO2. Right. So second method is what? By the thermal decomposition of the least reactive metallic oxides. Because 10th class, recall metallurgy chapter. So we have made three categories of metals: most reactive metals, moderate reactive metals, and the least reactive metals. Okay. So when the least reactive metals are there, so they go for the what, weak bonding. So when a moderate reactive is there, So little strong bond is there because they react, reactivity matters. And when you go to the most reactive metals, they go for the strong bond. So depend upon the nature of bond. So we have adopted a method to separate the metal or to reduce the ore into metal. Okay. So in the case of least reactive metal compounds or the metal oxides in general, in special, in particular. So because the bond is weak, heat alone is sufficient. So that's why the same knowledge is made use here. So there we learnt how the Illingham diagrams are made use in explaining the conversion of oxides into metals. So this chapter, this year it is a deleted portion. Otherwise, we would have extended the 10th knowledge to 12th class also, but no problem. So we don't require it. It is not so important. So by the thermal decomposition of least reactive metals where the bond is weak, we can rupture easily with less amount of energy. So we have gone for the that method also. So method number 1 is what? Oxygen rich compound. Method number 2, least reactive metal oxide, especially the D block. So just before the right side, so there are some metals, they are called as least reactive. So those reactive oxides, least reactive oxides will handle in the laboratory. And other is what? Peroxides. You can go for sodium peroxide, you can go for the any other, because peroxides where you find the ON is not a normal, it is abnormal. So the abnormal ON will make use when the abnormal ON is there. So we have the not that much stability. So when we have not that much stability, so it is a plus point for us to decompose. So all the reactions, that is the preparation parts of oxygen, are heat reactions. They are called as the pyrotechnics or the thermal decomposition, thermochemical reactions. So either by using a oxygen rich compound or by using the oxides of the least reactive metal or by using the unstable peroxides. So we can go for any method. Ultimately our aim is to get the oxygen. So oxygen is prepared by various methods. Okay, these are the some 3 methods we are discussing. Why oxygen is in full demand? Because it is required for most of the oxidation reactions in the industry, and especially for the patients. I think you might have heard last March, April, May month where we faced the shortage of oxygen in the corona time. It was a peak at the time in the March, April. So one small incident I want to narrate. Anyway, it is related to the topic. So there was a patient at about age was around 55. So that patient admitted in the hospital due to corona positive, and he was facing the shortage. It is a breathless problem, breathing problem. So immediately he was given. That time it was available oxygen cylinder. So he got cured. He was all right, and he came out of the hospital. But before discharge, he has to pay the bill, no hospital bill. So that bill, he went to the counter. It was around just for 1 or 2 days he was there. So around 76,000 bill. So that poor man, he was a poor man. He was a normal farmer. So he said, so bill is that much. He started crying. Then doctor asked, why is it difficult for you to pay? No, no, sir. Problem is not paying the bill. I admitted only 1 or 2 days only. So for 1 or 2 days, the bill is around 70,000 rupees. Just that only for giving oxygen. Other medicines already have purchased. Just for admission, your bill, hospital charge and the oxygen cylinder, you are charging 70,000 rupees. I'm ready to pay, but why I'm crying is nature has given oxygen free of cost for many years. How much you have to pay to the nature? Huh? So suddenly doctor started crying. So by listening to those words, so immediately he made 50% less because of his nature, okay, the formal nature. So he was given only around 25 to 30,000 rupees bill, and remaining is waived off. And, doctor only paid. So doctor also was good, patient also was good, and the condition also very good. So what I am seeing here, the use of
Sir,
oxygen.
your voice is cracking, sir.
It is cracking some area, not everywhere.
Sir,
Okay.
not able to hear it properly.
Is it to everyone or only for few?
No problems.
That's why.
Only for you,
It,
sir.
it
No, no
depends upon
problem,
the
sir.
it depends upon the area exactly how the net is available. So how the Webex app cooperates with us. So all that matters are there. But please wait. Please wait. So
Yes.
we were discussing what about the importance of oxygen for breathing. Naturally we breathe, but when we are sick, we are unable to breathe because of the that problems we have already gone through. Lungs is blocked, so it is a CT scan. All those problems are there. That time we give by artificial way. So for that purpose, we have to prepare oxygen. It is kept. It is not kept ready because we have to bring some chemicals, decompose, filter, purify. That this many techniques are there. So therefore, oxygen cylinders are very in full demand. Okay. So after understanding three methods, on large scale, it is prepared by two methods. Both are natural methods. Both are best methods. Both are giving very good result. Method number one is what? Using air. So in the air, it is freely available. Only thing is you have to separate. Depend upon difference in the boiling point. That what we learnt in the ninth class, liquefaction of air. So we are converting gaseous air into liquid air. So after converting the liquid air by using some special cryogenic techniques, so we separate the oxygen and the nitrogen. Then we send nitrogen to the fertilizer industry and oxygen to the hospitals area. Okay, right. So that is one method. Second is you can take 3/4 of our earth is covered by water, ocean. So collect the ocean water, purify it, make it only H2O by removing all the minerals and salts. That H2O is decomposed electrolytically in the laboratory on large scale. Okay. Then also we will get oxygen, hydrogen. Hydrogen is sent to the again rubber industry, fertilizer industry. Okay, or hydrogen as economy, all those, and oxygen once again sent to the water, that medical field, so that patients will not suffer any problem. 1, 2, 3, 4, 10, 20. If patients are there, then the hospital will manage cylinders. Suddenly hundreds, 200, 300 patient comes means that is the problem. Right? Oxygen is available, but getting cylinder right time in large amount is very difficult. That was the problem. So, but the government has made through helicopters. So, shifting of oxygen cylinders through trains, through goods trains. So, many methods they followed last time. You may be knowing. Okay. So, let us give thanks to those pilots and the railway, the the one who pilots, railway pilots. Okay. So, thanks to them for reaching the cylinder right in time to the hospitals. Okay. Right, giving cylinders and taking the empty one, again giving empty one. So their work is tremendous that time. Now conditions okay. So we pray God that this will subside at the earliest. Okay. So after understanding the two important methods which on large scale, electrolysis of water and the liquefaction of air, so we carry out the preparation of water, oxygen. Okay. So though we prepare, but still it contains some impurities. So again, further finally, it is purified by the fractional distillation, depending upon again boiling point. So at the end, we get water, purified, almost purified oxygen, that is sent to different parts of the area where it is used. And regarding properties, as you know, it is colorless, no color to the air. So because it is colorless, no odor, so no taste, and it is very sparingly soluble. Okay, around 33 what gram, or in terms of cubic centimeter, it is 3.08 in 100 cubic centimeter, and this is enough for the aquatic life, because aquatic life, their life is different, our life is different, our metabolism is different, their metabolism is different. So that all you learn in the biology. So whatever amount of oxygen is there in the water, that is called dissolved oxygen, that is enough for the aquatic animals. Okay, right. Now important part is regarding the chemical properties, because it is oxygen. So whenever oxygen reacts with, whether it is metal or non-metal or metalloid, any element, expected product is oxide. Okay, oxide. Okay, right. So when oxygen reacts with any element, it is most reactive. So at any element we get the oxide. Okay, here are some examples. And one important point is what oxygen is double bond, O double bond. So it is difficult to break the bond. Therefore, we require some extra conditions whenever we carry out oxygen reactions. So in the case of nitrogen, in the case of oxygen, because of triple bond and double bond, so we require some extra heat or extra conditions. So that's why. So using those drastic conditions, we carry out reactions. Once the reaction starts, it proceeds on its own. Okay. So with metallic oxide, with non-metallic oxide, with compounds molecules also metallic oxides. So depend upon the type, oxides are there. Oxides are there. And if it is already oxide, it will go for next higher oxide. For example, sulfur dioxide. Already it is oxide. But further reaction with sulfur dioxide gives what? Next oxide, that is sulfur trioxide. Okay, this we have made use maybe in the 15th group or in the sulfuric acid. No, no, we will use in this.
Sir, what
This
is the name of that catalyst? V2O5.
vanadium pentoxide. It is vanadium pentoxide. This property, this reaction we make use
General name, sir?
generally only vanadium pentoxide. It is general name only V2O5, P2O5,
Yes.
phosphorus pentoxide, V2O5, vanadium pentoxide, N2O5,
Yes.
nitrogen pentoxide. So this is what vanadium pentoxide, best catalyst. Okay. So this reaction we make use in the preparation of a sulfuric acid. Okay. So when we start the sulfur, there we understand this equation once again comes. Okay. And with oxygen also reacts with what? Ammonia. So ammonia and oxygen becomes what? Nitric oxide. The same nitric oxide we made use in the preparation of what? HNO3 by the Oswald process in the 15th group. So oxygen is playing very important role. So as in to prepare oxide, and those oxides will play some role in the preparation of some other important chemicals in the industry. So it is called as what? Industrial chemistry. So with HCl also it reacts to give chlorine, and here we are making use of what? Chlorine preparation. So to prepare chlorine, to prepare sulfur trioxide for sulfuric acid, to prepare nitric oxide for the HNO3. So for all these important chemicals, we use oxygen as the starting material. Okay. First we get the oxide, then we convert the oxide into required compound. Okay. And regarding the uses, the first and the foremost use is breathing. All we know. So apart from breathing, which is common use, so other uses are it is welding purpose, because we have seen in the welding area where in the cylinder it is acetylene gas is there. So when the acetylene and oxygen comes in contact with each other, it burns and gives a lot of energy, and that energy is enough to melt and to joint where the crack is there, where the joint is required. So all that we do in the welding or soldering area using the some alloys or directly some using some metals. So due to the high amount of energy, so metals will be in the liquid state, and then those metals are placed where it is required to join the water cracked or any a circuit you have to give connection. All those we use oxygen as a fuel, as a to start to burn. Okay, that is called all those are called as what? Oxyacetylene weldings. Okay. Then in the hospitals, all earlier I told, and whenever you go for adventure activity like mountaineering to climb Mount Everest, there we face shortage of air, shortage of oxygen. So that time you have to carry oxygen cylinders on our back. Okay, and when you want to study oceanography, to go deep into the ocean to study animals, animal kingdom, life in the water. So all that we require oxygen cylinders. Okay, so for adventure activity and for every day to survive. So for all those oxygen is very much required. Plus rocket technology, space work. Okay, I want to conquer the space. I want to go to moon. I want to go to Saturn. I want to go to what other planets. So for that we require satellites, rockets. So for all that we require, we have to burn. So there liquid oxygen or oxygen along with dinitrogen tetroxide or oxygen along with some special chemicals. So all those are clubbed, mixed. Ultimately, we get large amount of gases. So they will move downward, so that rocket moves upward. All this theory, propellants, we learn in the physics. Okay, right. Now we'll come to the oxides chapter. Okay, because oxygen it reacts with more all the elements and becomes oxide. So in brief, let us have idea about the oxide. So oxide means what? It is a binary compound. Bi means two. So it is a compound of two. Out of two, one is oxygen guarantee, because if oxygen is not there, then no oxide. Okay. So oxygen has to be there. So then other one is left to us, whether it is a metal or metalloid or non-metal. So an oxide is a binary compound of oxygen with any element. Simple definition. Okay. And a variety of oxides are there. So this chart will give us an idea. that how oxides are classified. So let's have an idea. Oxides are classified as a simple or mixed. So simple means what? Normal. Hmm? So whereas mixed means what? Fe3O4 is taken as FeO plus Fe2O3. So this is called as the ferroso-ferric oxide. We have heard ferrous oxide, we have heard ferric oxide. They are normal oxides, simple oxides. Okay, left side. Whereas on the right side, mixed oxides means two oxides are mixed in a different proportion, and we get a mixed oxides. In the same way, Pb3O4. So all those are called mixed oxides. This is one way. Another way is what depend upon their character, behavior towards the acidic property. So they are classified as in the simple only acidic oxides, basic oxides, amphoteric oxides, and neutral oxides. So acidic means what? So acidic property dominates, or they become acid when they are put in the water. Normally, this type of oxide will get from metallic side, extreme left or middle D and F, not with the right. If you want acidic oxides from the right side, then you have to go to the right bottom. So where all you will find a metal, so their oxides when they dissolve in water, they convert into water bases, and they are called as what? Basic oxides. Whereas acidic oxides are formed from the non-metallic oxides. So basic oxide from the metals, acidic oxides from the non-metals, nitrogen oxide HNO3, phosphorus oxide phosphoric acid, carbon dioxide carbonic acid. Okay, so all those acids are formed from the non-metals. So non-metals are we normally find on the extreme right side of the periodic table, that too right bottom metal, right top non-metal general survey. So those non-metallic oxides, when they put in the water, they convert themselves into what? Acidic oxides. So basic is what? As usual, metallic oxides. Okay, and amphoteric oxides. Okay, amphoteric oxides are what? Amphoteric oxides are, they react with what? Both acid and the base. Okay, so in the case of acidic oxides, they react with what? Basic oxide, because they are acidic in nature. When they are acid, they react with base. In the case of basic oxides, they react with acids. So here amphoteric is what? Amphoteric oxides are the oxides which react with both zinc oxide, okay, aluminum oxide. So one reaction is given at the right below in the rectangular box, where aluminum oxide is reacting with Cl as well as NaOH. Please, with the NaOH, I have written Al. It's not Al, it's Al2O3. Okay, please make it correction. So Al2O3 with Cl as well as NaOH, they give corresponding compounds of the coordination compound. That means what? The idea behind the reaction is what? It reacts with both. Okay, and only those oxides are called as amphoteric oxides. What is neutral? Neutral is they will not react first. At least amphoteric will react with acid or base, but here neither with acid nor with base. They don't show any property, acidic property or basic property. Therefore, they will react to someone, but not with acid or base. So therefore, they are, because they are not reacting to the acid or base, it is neutral. Okay, so best example is carbon monoxide, nitrous oxide, laughing gas. So these are neutral oxides. So their role is different. We come across in different area. So on different ground, as a simple mixed or acidic, basic, neutral, amphoteric. Okay, all those are there. And one more is there. We learn in the in water. In short, in afterwards, they are what? Oxides, normal oxides, peroxides, superoxides. All those are there, where we find this is done on the basis of what? Oxidation number of oxygen. In the normal oxides, simple oxides, we have where O is the -2, whereas in the case of peroxide it is -1, and in the superoxide it is -half, and all those suboxides we have learnt. So all those comes under the classification on the ON ground. So on different ground we classify oxides. Now the most important, okay, oxide of oxygen. Oxide of oxygen. So ozone, allotropic form of oxygen, O3 and O2. These two are allotropic forms of what? Oxygen in different form, carbon in different form only. Okay, so just have an idea about the bonding. So this is one is double bond, one is single bond. But from the 11th class knowledge, what we learnt, double bond will be keep changing that delocalization of the pi electron. So we are allowed to write bond anywhere. That is called resonance hybrid structure for ozone. This is one small structure, old structure I brought. Okay, right. O3 ozone. O3 bond parameters. So please go through all those data. Bluish in color. So it is one of the what powerful oxidizing agents. Okay, many are there. So this is the best oxidizing agent that is powerful because all are O only. All three are O. So oxidizing agent will supply O, but this is already O is there. So immediately reacts and forms into oxides. Okay. So therefore it is called as the powerful oxidizing agent. And it is highly unstable thermodynamically. So that's why high amount, high concentrations in some area, so it will go for instability or it will explode. Explosion means what? Unstable. Okay, so that's why. So it undergoes change to oxygen once again, and the changing oxygen ozone to oxygen is highly what exothermic. That's why we have a large amount of energy given out to. So it is said thermodynamically unstable, and it is also arose naturally as a byproduct of photosynthesis and the rise of atmospheric oxygen. Okay, so whenever oxygen amount is more in the atmosphere, so by nature process, cosmic process, so it converts into what? Ozone and adds to the next layer of the atmosphere. So that all happens in the nature. It is not in our control. So nature is taking care of us. Okay, and shields against harmful solar UV radiation. This all we know from 6th class. Okay, so stratosphere is a natural umbrella. It is a envelope cover, so protecting human life on Earth. So by absorbing harmful ultraviolet radiation. So our skin want normal radiation, not the ultraviolet. Okay. So because the skin contains some cells, they are highly sensitive. So they are burnt. So they are destroyed by the strong ultraviolet rays. Thereby we have skin cancer. Means skin covering only undergoes cancer, then other complication starts. Therefore, not to happen that one. So God has given, nature has given some shield cover. So that is called what? Ozone layer. Okay, so nature has given everything. So only thing is we have to use judiciously and wisely. So important for almost all of life on Earth. So let us protect the ozone layer. So we say yes, every year we say, but still depletion is going on, destruction of ozone is going on. So who will listen? So government has to take strict measures. So if it takes strict measures, then there is no development. So in the name of development, what to say, what not to say, all are debatable topics. Okay, so only situation will decide. So if it comes, we have to face. Otherwise, people are now aware, so they are not going for that much pollution. So they are usually using wisely the vehicles and all those. Anyway, let us see what happens in future. We will see. We will say not to please protect ozone layer, but how far practically human beings are using in the life, we don't know. So ozone, this is called ozone's native place. How we have our native place, no? So like that, native place of ozone. Ozone is available in the stratosphere, just above the troposphere. There are the spheres of our atmosphere. So tropo, where life is there, many things will come, cloud, all those. So most of the common things happens in the tropo only. So strato onwards, it is not in our hand. It is the cosmic area, where the space area. So solar system, that again star, galaxy, Milky Way, constant, all this will happen. So stratosphere, the second layer where we find the ozone. Yeah, it is from the surface of the ground. It is approximately between 15 to 20. So beyond 20, it is taken actually. So that range is called as what? That is called stratosphere. So 20 onwards it starts.
Sir,
So
formation of ozone is endothermic or exothermic, sir?
ozone is endo,
Yes,
oxygen is
sir.
exo.
Yes.
Oxygen to ozone. See, the fourth point is very
Oxygen to
important.
ozone is endothermic, sir.
Ah,
And
here the
ozone to oxygen is exothermic.
ozone to
Oxygen.
no formation of ozone
Yes, sir.
endo.
Yes, sir.
Ah. Let us see the fourth point. Wind blows horizontally because of this more aeroplanes fly with great speed and long distance. This is the why the air traffic control ATC is allowing planes are normally above the clouds, just in the troposphere only, but in the stratosphere supersonic jets, okay, because if they are in the troposphere now we get a strong noise highly, our eardrum will collapse, so strong noise. So that's why they are not allowed to fly in that area. So only in that area they are flying in the stratosphere. But the problem is, though we are developing jet plane, that this supersonic, okay, but we are destroying the ozone layer. That is the part. So I said already few minutes back, no answer. Okay, let's see. So progress and pollution both will hand in hand they go. So 90% of ozone lies in the stratosphere. So some portion in the tropo, and that tropo will be added to the once again strato only. It is keep changing. Okay, so but maximum 90% of ozone is available in the stratosphere. Only thing is we have to protect the that stratosphere ozone layer. Hmm? So just now I said we will have the area. So in the troposphere only we all do our activity, human activity. Okay. So including aeroplane, adventure activity, all those. But after the troposphere starts the jet engine, all those. So problem starts there only. Hmm? So where there is a ozone, we are carrying out some experiments. Hmm? So mesosphere, thermosphere, exosphere, all these are spheres above the atmosphere. Accordingly, what can be done in the physics, it is given. So only the physics will give answer to all these questions. Now, preparation of ozone. Okay, ozone is a must actually. Though ozone is there in the stratosphere, so we will not go to ozone layer to get the ozone. In the laboratory, when we require, we prepare it. Okay, so how the ozone is prepared, so that will study now. So for the ozone preparation, we require O2. Sorry, it's O2 to O3. So 3O2 becomes 2O3. 2 3s are 6, 3 2s are 6. Okay, so this conversion we will do in the laboratory. So you see from the energy level diagram also, it is very clear that the products are on the higher level compared to reactants. That's why it is plus 142 kilojoules per mole. So energy is given to convert oxygen to the ozone. Okay, highly endothermic reaction. So delta H is positive. So it is, that's why, and one more is it is carried out in the silent electric discharge. Okay, so let us not give too much energy, too much spark, because when too much is given, again ozone decomposes. Again it decomposes. That's why. So silently using some special devices, electric arc furnace discharges, all those techniques will follow in the higher IITs, ISC. So where we carry out O2 to O3, and even by doing this much also, what happens? We don't get a large amount of ozone. Okay, hardly around 10 to 20% we get. It is converting. That means what? Whatever we get the product contains not only ozone, along with ozone, some unreacted oxygen is there. Okay, so that's why the product is called as what? It is called as ozonized oxygen. So sometimes for 1 mark. So what is meant by ozonized oxygen? So ozonized oxygen is what? It is the ozone which contains what? Oxygen also. So this happens when we carry out the preparation of ozone from oxygen. Thereby to convert is very difficult, but still we carry out some experiments. So only 10 to 20% oxygen is converted, remaining is oxygen only, and that is called as what? Ozonized oxygen. And afterwards we carry out the purification. We take to the what cryogenic part, fractional distillation. So difference in the boiling point of ozone and the oxygen. So oxygen comes out because the boiling point of liquid oxygen is very less. It is in the minus. So first it is O3 comes out, then the oxygen will be left behind. So in this way, we will go for the fractional distillation followed by the liquefaction of the air. All those techniques are there. Ultimately, at the end, we get the ozone. So because we follow many techniques here, that's why ozone is costly in the market. Hmm? So whenever we go for tough method, many steps to get the one particular product, then cost becomes more. So method is very simple, then we get a cheap. See, to get the sodium chloride salt, very cheap. It's very simple method. Just collect the ocean water and go for evaporation. Small purification. Salt is ready of 25 rupees or 5 rupees. Very easy. So when the method is simple, then the product is damn cheap. If methods are very tedious process, boredom, high methods, then the cost factor increases. So that's why. So depending upon the type of method, we fix the cost in the market. Oh, sorry, it is Webex is saying what is time now? Oh, it is 11:10, 11:13. Okay, Webex is already saying. So in this way, we prepare ozone by oxygen and we purify it. At the end, we get the ozone. So what we'll do tomorrow? So we discuss properties part of the ozone. Then we'll go to the other parts of the group 16th member. Okay. So it is already time out is running. So without seeing the time, I was see, we don't feel when time goes. So ozone, oxygen, very interesting small chapters. So when the boys are with you, 76 boys are there, no? So we don't see the time power. Okay. Anyway, thank you very much for being with me with the preparation of ozone, especially. And tomorrow we discuss properties and uses of ozone. Further, we'll continue group 16th elements. Okay. Till then, have a nice time and thank you and all.
Thank you, sir.
Thank
Thank
you,
you. Thank
sir.
you very much. Thank you.
Thank you, sir.
Oh, thank you, my thank you. Very good. Fantastic.